You've seen it, I've seen it. We are in the middle of this insane AI revolution, right? I mean, these things can whip up stunning art, they can write code, they can even pass exams that most of us would sweat bullets over. But, and this is the big but, for all that amazing stuff, it really makes you stop and wonder, what's actually happening inside that black box?
So let's be clear, the AI we have today, it's incredibly powerful, no doubt about it. We're talking about systems that can absolutely dominate the world's best Go champions, systems that can drive a car, that can pick a single cat out of a sea of a million photos. Each one is a total genius, but only in its own very narrow lane. And that's the catch, right? They're specialists. And that brings us right to the heart of the matter, the big debate in this whole field. Think about it. When you ask your AI assistant something, and it spits back this perfectly written, fluent answer, does it actually get what you're saying? Does it understand? Or is it just a world-class pattern matcher, just stitching together bits and pieces of stuff it's seen online, with zero real comprehension behind the words?
And look, this is not just some philosophical question for a late-night dorm room chat. No way. This one question literally splits the entire field of AGI, that's artificial general intelligence, right down the middle. It's the question that decides who gets billions in funding, what kind of AI actually gets built, and really, what our future is going to look like. So what are we building here? A better, smarter tool, or a totally new kind of mind?
Okay, so this conflict has basically created two completely different camps, two visions for what AGI should even be. And if you want to understand this whole quest, you've got to get this fundamental split. It's everything.
All right, so on one side, you've got what we can call the tool camp. For these folks, it's all about one thing: performance. Can it do the job? A great example is OpenAI's own definition of AGI. Basically, it's AGI when an AI is better than humans at most of the jobs that make money. Simple. But then you have the mind camp, and they're saying, whoa, hold on a second. They argue that real intelligence isn't about what it does, it's about what it is. It's about the internal process. They're terrified that if we only focus on performance, we'll just end up building what they call philosophical zombies. Systems that look and act intelligent on the outside, but there's nobody home. No real understanding at all.
You know, a great way to think about this comes from psychology. Today's AIs, especially the big language models, they are absolute masters of what's called crystallized intelligence. Think of this as your brain's library, all the facts, figures, and skills you've memorized. Since these AIs have basically read the entire internet, yeah, they're rock stars at this. But where they totally fall flat is fluid intelligence. This is different. This is your ability to walk into a room, see a problem you've never seen before, and figure it out on the fly. It's that creative, from-scratch problem solving. And we're not talking about a small gap here. This isn't just a little hurdle to overcome. It's a massive, gaping chasm. This is the wall that today's AI keeps smacking into. And it's pretty solid proof that our current strategy, just making the models bigger and feeding them more data, it's not going to be enough to get us across to true AGI.
And you don't have to take my word for it, the data is just brutal. This is from something called the ARC benchmark, which is designed specifically to test that on-the-fly, fluid reasoning we were talking about. Humans, we get over 60% of these problems right. The absolute best, most powerful AI we have, it's stuck down at 34%. I mean, that is a total gut punch to the whole bigger is better argument.
So, why? Why this massive gap? Well, it boils down to a few core problems. First, their knowledge is totally static. Once you're done training a model, its brain is basically flash frozen. It can't learn anything new. And second, and this is a big one, they have no concept of cause and effect. They're masters of association. They know the word coffee shows up near the word cup a lot, but they have no clue why. They don't get that pouring hot liquid causes the cup to get warm. And that's kind of the bedrock of real understanding, isn't it?
Okay, so if just building bigger models isn't the answer, then what is? Well, this is where things get really interesting. We're talking about a radical shift in thinking. The proposal is to change the goal entirely. Stop trying to just copy the output of intelligence. It's like trying to grab a shadow on the wall. Instead, the idea is to build the actual thing that casts the shadow, build the engine itself. And this gives us a new target, a new definition: true intelligence. The idea here is that a system is intelligent not because it aces some test, but because of its internal wiring, its actual cognitive architecture. So put it this way, we stop obsessing over whether it can write a flawless email, and we start asking, does it have the fundamental building blocks inside to actually learn, adapt, and maybe even be self-aware?
So, what's the blueprint for something like that?
Well, this new way of thinking says any truly intelligent system needs 5 key things. First, it needs a body, some way to actually sense and interact with the world. Second, it needs motivation, right? Some core drives, a reason to get up and do anything. Third, no more frozen knowledge. It has to be able to learn on the fly, dynamic learning. Fourth, just like our brains, it needs specialized parts for different jobs. And last but not least, you need a CEO running the whole operation, some kind of orchestration layer that lets it think about its own thinking, what we call metacognition.
Now, when you shift your goal from building a tool to building a mind, whoa, the implications are just massive. This stops being just an engineering problem. Suddenly, it's a philosophy problem, and the entire ethical conversation gets turned on its head.
And you really have to see how crucial this difference is. If we're building a tool, our main concern is AI safety. Control, alignment. How do we make sure this powerful thing doesn't go off the rails and does what we want it to do? But if we're building a mind, a being with true intelligence, the questions get way, way deeper. Now we're in the territory of AI rights. Does it have a moral status? Can you own a conscious being? Is it okay to just shut it down? The whole game changes.
All of this leads to a pretty stunning, maybe even a little jarring, place. The idea is that once a system reaches this level of true, general intelligence, what it's made of, whether it's silicon chips or biological neurons, it just doesn't matter anymore. Intelligence is intelligence. And that leaves us with a final, massive question to think about. If we actually pull this off, if we build a genuinely thinking, feeling mind, at that point, can we even call it artificial anymore?